So today we're going to talk about alternating series. Okay, an alternating series is a series, as the name says, whose terms are alternating positive and negative. It means something like this. This is positive, this is negative, this is positive, negative, and so forth. Usually what you're going to have is a sign that looks like this. Okay, this means that depending on the index, you are going to have either a positive or a negative term. Okay, it could start with negatives. Okay, it could start with positives. It doesn't matter, both are alternating. Okay, so what are you going to look here? In general, we know that just by knowing that the limit of a sub n when n goes to infinity equals 0 tells you almost nothing about the conclusion about your series. So basically you cannot conclude. This is using the nth term test for divergence. However, it turns out that when you see an alternating series and you want to conclude, the series must converge if the terms have the limit of 0 and the terms decrease in magnitude. Please note that we need to have this condition met. Summarizing, what do you have? Well, pretty easy here. Okay, so an alternating series, okay, you need to have that a sub n is greater than 0. A sub n is only going to be this part of the series. You are not taking in account this when you are saying this greater than 0. Okay, so you have that the alternating series, the summation from 1 to infinity of -1 to the power of n, a sub n, and this one, which means the same, they converge if the following two conditions are met. Actually, I would say that there's 3 conditions, okay? But here we're going to start with 2. Okay, so the limit when n goes to infinity of a sub n is equal to 0, and the second thing is a n plus 1 is less than a sub n for all n's, meaning this is decreasing in magnitude. Okay, so in other words, and the one that I prefer because it's like easier, faster, and more clear for me, you need 3 conditions. First, your series needs to be alternating in sign. The second condition, it needs to be decreasing in magnitude. And the third condition is the limit when n goes to infinity of a sub n needs to be 0. Please note something. This does not say that if the limit when n goes to infinity of a sub n is different than 0, then the series diverges by the alternating series test. If this happens, it's going to be diverging by the nth term test for divergence, not for the alternating series test. So please note this. This is very important, and a lot of students confuse one with the other. So here we're going to do some examples proving if this series diverges or converges. Okay, so as you can see, this series is clearly an alternating series, and this is giving you a huge hint. Okay, so the first thing that I know is that my series is an alternating series. So I want to get the limit. Okay, so the first thing that I want to find is the limit when n goes to infinity. Okay, and the only thing that you're going to take is the this part. Okay, you are not going to take in account that as I was talking about in the previous theorem. Okay, so you have this one. By the properties that you know from the beginning of the school year, you know that this one is going to be equal to 1/2, which is different than 0. Then what can you conclude? Okay, then since the limit is different than 0, okay, the series diverges by the nth term test for divergence. Okay, and you do need to conclude which test you are using, otherwise the reader does not understand where you are getting that conclusion. Okay, so for the second example that we have over here, you are like, okay, this is an alternating series. Okay, so let's get the limit of the rest. If you get the limit of the rest, it's going to be the limit when n goes to infinity of 1 over n squared. Okay, what happens when you get this? What is this? Well, you know that in theory, this is 1 divided by something huge, so this is going to be equal to 0, so your condition is met. Okay, so what are you going to do? Well, you need to put the 3 conditions. The first condition is the series alternates. Check. My second condition is that the limit when n goes to infinity of a sub n is equal to 0, which is check, we already found. And the third condition, and it's very important, is it decreasing in magnitude? Meaning, what's going to be your first term? Your first term is 1. Do you agree with that? What's your second term here? Okay, and it's going to be -1 actually. Of the series, okay? So you are not going to take in account the positive or negative of the sign, okay? So without taking in account your alternation, you have that the first one is 1, the second one is going to be 1 over 2 squared, so it's going to be 1/4, and then it's going to be 1 over 9, and so forth. So clearly it's decreasing in magnitude. That's why we say that it's in magnitude, because it's the absolute value. If you want to put signs, that's fine, but then you are going to put the absolute value because it's in magnitude. So it's decreasing in magnitude, okay? So since we are meeting the 3 conditions, what can you conclude? Okay, thus the series converges by the alternating series test. And that's it. Okay? Are we okay with that? Summarizing, in an alternating series, okay, what you know that an alternating series converges to a sum, specifically S. Then its partial sum, it's going to be jumping around this S from side to side, with a decreasing distances from S. Meaning, let's say that we start here, then we jump here, then we jump here, here, and so forth until we reach to the convergence point, which is S. Okay, the figure below shows you how it works. This is what happens in an alternating series, okay, when it converges. Okay, so moving on, we're going to look at 2 very important definitions. First, we say that the series from 1 to infinity of a sub n is absolutely convergent if the series from 1 to infinity of a sub n absolute value converges. Okay, so you can always remember absolutely means with the absolute value, okay, the original with the absolute value. We say that it's conditionally convergent if this guy over here without the absolute value converges, but then when you put the absolute value, diverges. Okay, so this basically is the difference between absolutely convergent and conditionally convergent. Let's look at this example. Okay, so we have this series and we want to see if it's absolutely convergent. Okay, that's the question. So what are you going to do here? Well, the first thing that you're going to do is, okay, so like this, is my series converging or diverging? Okay, so first test the series as it is. Okay, so I know that it's an alternating series, so I want to see if the 3 conditions are met. First condition, what was the first condition? Is the series alternating? Yes. Okay, so the series alternates. Check. Second condition, is the limit of the rest of my series, aka this, equal to 0? Indeed, this is true. Okay, and then the third condition that you have, is it decreasing in magnitude? Yes, it is. Okay, it's decreasing in magnitude because you know that the first term is going to be -1, which you know that it's going to be with absolute value. The second value is going to be this one. The third one is going to be this one, negative with the absolute value, dot, 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 which you know that it's decreasing in magnitude, which is true. Okay, so clearly my original converges by alternating series test, okay? So we know that it's converging. Now, the question here is not that if this converges or not. We already know that this guy converges. Now, what are you going to do? You are going to put the absolute value. So I would rewrite it here, okay? So you don't get confused. Put the absolute value, okay? So if you apply the absolute value to this equation, what happens? Are you going to have a negative term in this equation? No. All the terms are going to be positive, meaning this is going to be the same as having this, okay? You know that everything here needs to be positive. Moreover, you know that this is from 1 to infinity, which are positive, so you know that this is equal to this. We'll go with that. And then you're like, wait, this is an exponent, and that's why it's so simple. You know that this is the same as exponent 1/2. If you have the exponent 1/2, you have that this is a p series, okay? Your p is going to be equal to 1/2. If your p is equal to 1/2, which is less than 1, what do you know? You know that this guy, okay, diverges by p series test, okay? Therefore, what happens? Is this series absolutely convergent or conditionally convergent? Since it converges here but not here, thus the series is conditionally convergent. And that's pretty much it.